Hi everyone, let's solve this problem. Find all positive integers c such that x squared plus cx plus 6c factors over the integers. Go ahead and pause the video and give it a try. Okay, if this quadratic polynomial factors over the integers, then that means it can be written in the form x plus u times x plus v for some integers u and v. Now if I expand out the right-hand side and then equate the corresponding coefficients, I find out that u plus v must equal c and u times v must equal 6c. Well, putting those equations together, we discovered that uv is equal to 6u plus 6v. So we're looking for integers u and v that satisfy this last equation. In order to do that, what I'm going to do is solve this equation for one of the variables in terms of the other. For example, let's solve for u. Here I'll factor out a u, and then I'll divide. So in other words, we have to find the integers v that cause 6v over v minus 6 to also be an integer. Now those values of v are not obvious when we see this expression in this form, but it will become obvious if I actually divide v minus 6 into 6v. You can do that with a standard polynomial division algorithm or synthetic division, or you can simply write the numerator as 6 times v minus 6 plus 36. And now you get 6 plus 36 over v minus 6. So again, u is equal to 6 plus 36 over v minus 6. So now it should be obvious which integers v cause u to also be an integer. All we need to ensure is that v minus 6 is a factor of 36. So I'm going to make a table, and in the first column of the table we'll put the possible values of v minus 6, which will be the factors of 36. And we'll start at the top and work our way down. So 36, 18, 12, 9, 6, 4, 3, 2, 1. And there are further negative integer factors I'll discuss in a moment. Now for each value of v minus 6, I want to know what v is equal to by adding 6. And I get 42, 24, 18, 15, 12, 10, 9, 8, and 7. Then I want to compute u. Now u can be computed by taking 6 plus 36 divided by the number in the first column. So 6 plus 1 is 7, 6 plus 2 is 8, 6 plus 3 is 9, 6 plus 4 is 10, 6 plus 6 is 12, 6 plus 9 is 15, 6 plus 12 is 18, 6 plus 18 is 24, and 6 plus 36 is 42. So I found all possible integers u and v here, at least for these positive factors of 36. And I want to get the corresponding value of c. Now remember, above we discovered that c is equal to u plus v. So I just need to add the numbers in these last two columns here, and I get 49, 32, 27, 25, 24, and now they start to repeat: 25, 27, 32, 49. So I'm finding some values of c here. Looks like I have 5 distinct values that satisfy the conditions of the problem. Just to illustrate what happens if we continue this table into the negative factors of 36, well, in all of those cases you can check that c comes out negative, and the problem required c to be a positive integer. So for example, if v minus 6 is negative 1, then v would be 5. And u, remember, can be found by taking 6 plus 36 divided by v minus 6. That would be 6 plus 36 divided by negative 1. That's going to come out to negative 30, and if I add those together, I get negative 25. And that's a perfectly valid value of c that causes the polynomial to be factorable over the integers, but we were required to get positive integers c. You can check that if you continue the table, all these values of c turn out to be negative. So these are the solutions: 49, 32, 27, 25, 24. Just to take one as an example, if c is 25 and we take a look at the given polynomial, then it would be x squared plus 25x plus 150, and that's supposed to be factorable over the integers, and it is. It's x plus 15 times x plus 10. And you can similarly check the other values of c. So hopefully you found all 5 of those. Thanks for watching the video.